Hello and welcome back. Now, one thing you're going to need to be able to do is recognize when you're looking at the equation of a sphere. Now, because of the nature of the equation of a sphere, remember all those squares are in it, x minus a squared plus y minus b squared, etc., that you can actually square those out, expand those squares, and what you'll get is something that doesn't quite look at first glance like the equation of a sphere. But we're going to do this for a lot of different things. There's lots of different geometric objects. We're starting with planes and spheres in this section. But given an equation that looks like this, we're going to need to identify what sort of geometric object this represents. In this case, I'm telling you off the bat, it is a sphere. And what we want to do is get the equation of a sphere, of what sphere this is. So that is, I want to identify what's the center and what's the radius. Right, if I tell you this is the equation of a sphere, that's defined by two things: the center of the radius, the center and the radius. That allows us to plot it and visualize it. So how do we recover the center and radius of the sphere? How do we recover the sort of typical sphere equation from this one? Well, the answer is we have to complete squares. Completing the square. So I know that that might trigger some of you a little bit back to, say, algebra class or pre-calc of having to complete squares. So we're actually going to venture back there. How do we complete the square for just dealing with one variable? So you might not have done this in a very long time. That's totally okay. The more times you learn something like this, the better at relearning it that you get, and the more likely you are to remember how to do it. So let's go again with how do you complete the square with just one variable. The idea is I want to write this thing, I want to write it like something like x minus h squared plus some constant k equal to 0, or alternatively, I really just want to get this x by itself minus something or plus something squared, equal to something else. I want to turn this into something that looks like this, because this is what we recognize in the equation of a sphere. Sorry, I was a little bit too far down there. I want it to look something like this. So how do I do that? Well, I need to remember what it looks like when I expand something like this out. That's my first step. X minus h squared, well, that's x squared minus 2xh plus h squared is what that looks like. So this center term, the coefficient on the x, there are two of them. And then we have an h squared here. So what I want to identify here is what the h should be. So if I go back down to here, I have x squared minus 2x equal to 3. I want to add something to this or subtract something in order to be able to simplify this. So I can notice here, generally I end up with twice, right? 2 times xh here. That tells me that my h should be 1. It should be half of this coefficient, 1. And so when I square that, 1 squared, I just get 1. So what I'm going to do is I'm going to add and subtract 1. Plus 1, minus 1. I still have this equals to 3 over here. And now the x squared minus 2x plus 1, that is x minus 1 squared. I still have this minus 1 hanging around, and I still have it equal to 3. So let's go down one more level. I'm going to write it with everything, all the constants over on the right side, because when we're working in 3 dimensions, that's typically how we're going to think of these things. We're going to move all the constants over to the right-hand side. X minus 1 squared equal to 4. And it gives me that. And actually, I can solve this a little bit now. This tells me my distance from 1 needs to be 2. And so that gives me 3. And negative 1 would both work for this. It gives me 2 points. So again, what I did is I looked at this coefficient in the x, I cut it in half, and then I squared it, and that told me what I needed to add and subtract. Now, for a sphere, we have to do this 3 times because we have 3 coordinates. So first step I'm going to do is I'm just going to get all my x's together, my y's together, and my z's together. So I'm going to write this like x squared minus 2x. So I'm not really doing anything other than invoking the commutativity of addition. Plus z squared minus 8z equal to negative 1. Equal to negative 1. I'm going to handle my x's. In fact, I just did this one. Half of 2 is 1. Square that, I get 1. So that's what I'm going to add and subtract. X squared. And rather than adding and subtracting it, I'm actually just going to add 1 to both sides. That'll balance it. That's another way to balance it. I could either add and subtract the same quantity from the same side. That's the same as adding 0. Or I can add the same number to both sides, which in effect, I'm still adding 0 to both sides of the equation. So I'll do x squared minus 2x. I want to add 1 to that because this will form a square. And then I'm going to also add 1 to the other side. So this negative 1 is now a 0. And then I still have my y squared plus 6y. And actually, let's deal with this. Let's deal with this as well. I'm going to actually do this in, I'm going to try and do this in just like one step. So I'm going to add, remember, I'm going to add 1 to this. I'm keeping track. When I did the x, I had to add 1. Y here, I have y squared plus 6y. Again, I'm going to cut the 6 in half. That's a 3. Square it. That's 9. And so I'm going to add 9 and subtract 9, which means I can also just add 9 to the other side. That's for the y I needed to add 9. And then z, take the 8, divide it by 2. That's 4. Square it. That's 16. So I need to add 16. And I also need to add 16 over here to balance it out. So negative 1 and 1, that gives me 0. 9 and 16, that gives me 25. So this is my next line. I've added all these constants so that each x, y, and z will be perfect squares. And let's keep going. So that means this x squared minus 2x plus 1, I can factor that. That's x minus 1 squared. The y's I can factor. This should be y plus 3 squared because it's a positive 6y. And then the z's, that should be z minus 4 squared. And that's all equal to 25. So now this is great. This is excellent. Look at this equation. This looks just like the equations of the circles we were just looking at. I can now pick out the center of my sphere as well as the radius. So the center is 1, negative 3, 4. Right? X minus 1, y minus negative 3. That's why there's this positive here. Notice those switch because we're dealing with distances. They switch. And then z minus 4, that gives me a 4. So center is 1, negative 3, 4. And the radius of 5. Remember, square root of this is my radius. So radius 5. So now I have, I've recovered the sort of general equation of a sphere. I don't know about general, standard equation of a sphere. And from that I can pick out the center and the radius. So that's how you can perform a problem like this. Again, we're going to, later on in the class, this is going to be taken to a next step. Given an equation that looks something like this, we'll have to be able to figure out, is this a sphere? Is this a plane? Is this an ellipse? Is this a hyperbolic paraboloid? We'll get to all these things later. Right now, we're just identifying spheres. I'll see you next time.